scheduled to cover the second session of Unit 3, right? We do have a leftover from the first section is the application of a quadratic function, but this specific problem is very time consuming. So I'm going to skip this problem for now, and then later we might go back if we have extra time, enough time to cover this problem. All right, so the second section of Unit 3 talks about the division of polynomials. I want to start from covering the definition of a polynomial. We do have a problem in Unit 3 exam that is about the definition of a polynomial. What is a polynomial? And last semester, we don't really have a very good passing rate on that specific problem. So I want to spend time to talk about what is a polynomial. Since we only consider polynomials in one variable, so the polynomial we are going to talk about are univariate polynomial, okay? Univariate means one variable. Okay, in order to understand what is a polynomial, we need to understand what is a monomial. Monotone, monopoly. Mono means one, right? Okay, let's see what is a univariate monomial look like. It looks like this. Anything that can be written in that form is a univariate monomial. This form has three parts. The first part is the number a, and a here is the coefficient. We call a here the coefficient of the monomial. And it is a number. The number could be any real number. Any real number. So a here as the coefficient of the monomial could be positive, could be negative, could be zero, could be a fraction, could be a decimal, could be rational, can also be irrational, as long as it is a real number. So that's the first part in the form. The second part is the variable base f. Most of the time, we use x to represent the variable in a polynomial. So sometimes the question uses y or other letters. It's just different letter. So here, the second part is the variable base. I always use x. The third part is the exponent on the shoulder of x. So n here is the degree of the monomial. We are talking about what is a univariate monomial, right? And n here on the shoulder of x is the degree of the monomial. It is the exponent of the variable x. And n here has to be a whole number. Very important. Differentiate between a and n. In this form, x is the only variable. A is a number, n is a number. A as the coefficient could be any real number. No problem. It doesn't have to be whole number. It could be decimal, any real number I mentioned earlier. But n here as the exponent of x, as the degree of the monomial, has to be a whole number. Okay. What are whole number set? What is the whole number set? Or let me change a question. What is the smallest whole number? Let me change my question. What is the smallest whole number? Is 1, -1, 2, 0? Yeah, what is the smallest whole number? Whole number. Anyone give it a try? Are you guys with me?
Yes.
Yeah. What's the smallest whole number? Okay, I'll answer my own question, all right? Just to make it more efficient. The smallest whole number is 0. Whole numbers include 0, 1, 2, 3, and so on and so on. All right? The smallest whole number is 0. And 1 and 2, 3, 4, 5, 6. And those are whole numbers. So as the degree of a monomial, n has to be a whole number. 0 is fine. 1 is fine, 2 is fine, 3 is fine, but cannot be -1 because -1 is not a whole number. Cannot be 1/2 because 1/2 is not a whole number. It has to be a whole number. I think the best way to understand what is a univariate monomial is to use the definition. I'm going to give you some expressions and you help me to determine are they monomial or not based on the definition I just explained. All right. So example, yeah. So example. Let me give you some examples. Let's say 2x half x2, x many 1, x many y, 10, 0, many 5. Okay. Look at this first one. 2 times x to the power of half. Let me repeat the definition. Anything, any expression, anything that can be written in this form is a monomial, univariate monomial if it only has one variable. It has to be univariate because this form only has one variable base. All right. So look at the 3 parts in the form: coefficient, any real number, base, variable base, could be any letter. I use x most of the time, and the degree on the shoulder of x. The degree has to be whole number. So is this a monomial? Is this a monomial?
Yep.
It is not, because the degree, the exponent on the shoulder of x has to be a whole number, right?
Oh, okay.
Yeah, whole numbers include 0, 1, 2, 3. 1/2, half. This fraction is not a whole number. Half a pizza doesn't make a whole, right? So for that reason, this is not a monomial. Okay, it's not monomial. What about this one?
Yes.
Is that a monomial?
It is because, hold on.
It is. This one is,
Yeah,
okay? This one is, the coefficient is a half. Coefficient could be fraction, no problem. The coefficient could be any real number, as I wrote here. And the variable base is x, degree is 2. 2 is a whole number, so this is a monomial with degree 2. All right, guys? What about this one? Bailey, is this expression a monomial? X to the power of 91. Bailey, are you there? Yeah,
Yes, I'm sorry. Can you say that again?
Oh, so I have x to the power of 91. My question was, is this expression a monomial? I explained the definition for monomial. Anything that can be written in this form is a monomial.
Okay. Are you asking if it's a
Yeah,
Sorry, are you asking me if it is one?
Yeah, if it is a monomial, is this expression a monomial? Eligible to be a monomial?
Yes.
No.
It's not?
No, the exponent is 91. 91 is not whole number.
Oh.
All right, guys, in order to be a monomial, the degree, the exponent on the shoulder of the variable base has to be a whole number. Did I say that? Did I say that earlier? The exponent has to be a whole number, all right? Okay, what about this one? Ether, is this a monomial?
It doesn't have a degree, it doesn't have a whole number.
Oh, that's a good question. I said anything that can be written in a form is a monomial. Look, can I write x as 1 times x to the power 1?
Oh, yeah.
Yeah.
I can see that one,
If I write x as 1 times x to the power 1, then it is the form, right? It's in this form. Coefficient is 1. Variable base is x. Exponent is 1. 1 is a whole number. So this is a monomial with degree 1. You see it? Okay. So it is a monomial, all right? It's a monomial with degree 1. Jose, is negative y a monomial?
No.
Why not? I can write it as negative 1 times y to the power 1. Coefficient is negative 1, right? Variable base is y. Normally we use x, but sometimes you could use other letters. Depends on the context. Y is okay to be the variable base. And the exponent on the shoulder of the variable base is 1. 1 is a whole number. It is, okay? Do you see it, Jose?
Yeah.
Okay, if you see it now, that's perfect. Yeah. Okay, the challenging one. Eliza, would you consider this expression is a constant term? Is this a monomial?
I would say it is.
You say yes? Okay, the answer is correct. But can you tell me what's the degree?
It would just be 1.
Is a 0. Yeah, but that's a challenging one, okay? Because we can write 10 as 10 times x to the power 0, right? Do you guys remember a formula you guys learned from Foundation 2? Any non-zero base to the power of 0 equals 1. Any non-zero base is raised to the power of 0 gives 1. So 10 equals 10 times 1, and we can write 1 as x to the power 0. If we write 10 as 10 times x to the power 0, that is in this form, right? Coefficient is 10, base is x, variable base is x, exponent is 0, 0 is a whole number. Is 0 a whole number? I have it right here. So it is. Your answer is correct, but this is a challenging one. Degree is 0, okay? 10 is a monomial with degree 0. Then similarly, this is also a monomial because we can write it as 0 times x to the power 0, right? And number 0 is also a monomial with degree 0. Similarly, number 95. This is also a monomial because we can write 95 as 95 times x to the power 0. So I can conclude here, very important, a constant term. Constant term means just a single number, right? Like 10, 0, or 95. A constant term is a monomial with degree 0. 0 is fine. 0 is a whole number. Okay, that satisfies the definition. Yeah, please have this conclusion in your note. A constant, a single number, a constant is a monomial with degree 0. It is a monomial. Okay, so we understand what is a monomial. I hope it's clear enough. Then what is a polynomial? What is a polynomial? If you have an expression and the expression is the sum of a bunch of monomials. In other words, if you have a bunch of monomials added together, you have a polynomial. Poly means many, right? Monomial, mono means one. And we already know what is a monomial. What does a monomial look like? If you have more than one of them, or one is fine, okay? Monomial is a special case of polynomial. If you have one or more monomials added together, you got a polynomial. For example, if we put, so we have those examples on the top right. If I take two of the monomials, okay, and add it together, 1 over 2x squared and negative 5. Yeah, if I put them together, add it together, I got a binomial. Okay, binomial. Yeah, bipolar, bi means two, right? Binomial. What is binomial? You add two monomials together, you get a binomial, right? So if I take one more, you know, x, I put it here, x. Now this expression has three monomials in it, right? This expression has three monomials added together, and that gives us a trinomial. TRI. Tricycle, triangle, tripular, tri means three, trinomial, right? If you have four monomials added together, we do not really have a specific name. They are just all called a polynomial. Monomial is also a polynomial. Binomial is a polynomial. Trinomial is also polynomial. Polynomial is one or more monomials added together. Please let me know if it's clear. What is a polynomial? Is that clear, everybody? Is that clear, everyone? Okay, thank you. Thank you, Jose. Any response? Oh, actually, it's Eliza. Okay. Any response is appreciated. So next very important topic is the standard form of a polynomial, okay? The standard form of a polynomial. Now that we know what is a polynomial, we need to know how to write a polynomial in the standard form. Now, what does the standard form of a polynomial look like? What does a standard form of polynomial look like? So let me give you an example, right? So for example, we have x to the power of 6 plus x minus 10, all right? So this is a trinomial. I apologize. I'm sorry about that. I apologize. My daughter's little. She's only 14 months. So this is a trinomial, right? As you can see, x to the power of 6 is a monomial, and x is also a monomial. Negative 10 is also a monomial, right? The first term is 1 times x to the power of 6. Coefficient is 1, degree is 6. The second term, coefficient is 1, degree is 1. The third term, coefficient negative 10, degree is 0. So we have three monomials. Added together, we have a trinomial. But this trinomial is not in the standard form. The standard form of this trinomial should have 7 terms. Why? Because the degree of the polynomial is 6. How do we determine the degree of a polynomial? How do we determine the degree of a polynomial? We know the degree of a monomial, right? If we have a bunch of monomials added together, we got a polynomial. Then what's the degree of the polynomial? The degree of the polynomial is the degree of the is the highest degree on the shoulder of x. All right. Yeah, the first term has degree 6, exponent 6. The second one has exponent 1. The third term has exponent 0. Among 6, 1, and 0, the highest is 6. So that's the degree of the polynomial. I hope this is clear. All right. So we also need to know what is the leading coefficient. Since x to the power of 6 has the highest exponent, this term is the leading term. And its coefficient of this leading term is the leading coefficient of the polynomial. So I'm recording the class. You can always rewatch the content. Okay, I received Bailey's message. So this is a trinomial with degree 6. Leading coefficient is 1. Okay, we are talking about main thing is the standard form, right? What's the standard form of polynomial? If the degree of the polynomial is 6, then the standard form should have 7 terms. We start with the leading term, right? X to the power of 6. And then do we have x to the power of 5? Do we have x to the power of 5? Ether, do we have x to the power of 5 in the polynomial?
X power 5.
Do we have it in the polynomial? This is the polynomial.
No, we have just x power 6.
Yeah, you're right. We don't. You're right. We don't. Because the coefficient is 0. Coefficient of a monomial is okay to be 0. We don't see it because the coefficient is 0, right? Same thing. We don't see x to the power of 4 because coefficient is 0. We do not have x cubed because coefficient is 0. We don't have x squared either because coefficient is 0. But we have x, right? Coefficient is 1, so bring it down. And we also have degree 0, which is -10, the constant term. So let's count it. 1, 2, 3, 4, 5, 6, 7, right? Degree 6, or exponent 6, 5, 4, 3, 2, 1, 0. Yeah, notice this term has degree 1, and this one has degree 0. We don't really normally write that out. So 6, 5, 4, 3, 2, 1 with 0, that is 7. Okay, if the degree of a polynomial is n, then there are n plus 1, that many terms in the polynomial, in a standard form. In a standard form of the polynomial. All right, yeah, it's good to include this in your note. It's hard to, grasp everything just in the class. You need to do some reinforcement after the class. So you should take notes. If the degree of the polynomial is n, then the standard form of the polynomial should have n plus 1, that many terms. All right. If any terms are missing, because the coefficient of the term is 0. All right, very, very important, very, very important, standard form. So the focus of this section is the division of two polynomials. So we talk about divide polynomials, divide one polynomial by another polynomial today. And firstly, I want to introduce, if we have a polynomial on the top divided by a polynomial on the bottom, so the fraction bar here with the numerator on the top, denominator on the bottom is equivalent to a division symbol, right? So this basically means polynomial p of x divided by polynomial q of x. Then the two polynomials play different roles in this division. And we call p of x the dividend. Is important. Dividend, we need to know the name, dividend. And we call the denominator divisor. All right, the top is a dividend, the bottom is divisor. And then the polynomial in front of the division symbol, dividend. the polynomial after the division symbol divisor, okay? And we only talk about when the degree of the dividend, we use P of X dividend, is bigger than or equal to, or most of the time actually just the bigger than, is bigger than the degree of the divisor, Q of X, okay? And in the case, degree of the numerator is smaller than the degree of the denominator, we do not cover that in this section. Next section, we are going to talk about what is the result when we divide a polynomial with a lower degree by a polynomial with a higher degree. And today, when we talk about dividing polynomials, the degree of the numerator always bigger than the degree of the denominator, all right? Two methods. The first method is the long division method. Okay, I'm gonna explain the process of long division by using this problem. Firstly, we need to identify what's the dividend, what's the divisor. This is a quotient, right? Two polynomials involved. The polynomial in the numerator is the dividend. Polynomial in the divisor, in the denominator is the divisor. All right? Anybody can tell me what's the degree of the dividend? Anybody can tell me what's the degree of the dividend? Baby, could you help me out on this one? Degree of the dividend, the polynomial above the bar, 2x cubed minus 4x squared plus 7x minus 8. Hello?
I'm sorry, I can barely hear you.
My question was the degree of the dividend in this problem. The numerator is the dividend.
Yes.
It is 2x cubed minus 4x squared plus 7x minus 8. What's the degree of that polynomial?
It is. Wait 1 second. It's 3.
Exactly. Thank you. Appreciate
You're
that.
welcome.
And
Sorry, I don't know what's going on with my phone. The speaker's messing up.
it's okay. That happens. And so the dividend has a degree 3. Remember, 3 plus 1, 4. Supposed to be the number of terms in the dividend, right? In the polynomial, in the standard form. Since numerator has 4 terms, 1, 2, 3, 4, and it's in the descending order of the exponent, 2x cubed minus 4x, squared, minus 4x squared, 2x cubed minus 4x squared, plus 7x minus 8. So that's the dividend. And the dividend is already in a standard form. Very, very important. When we apply the long division to divide two polynomials, we have to make sure they are both in a standard form. Dividend, yes. Let's see the divisor. Divisor is 2x squared plus 5. Jose, what's the degree of the divisor? Jose?
I'm sorry, can you repeat that, please?
The divisor is 2x squared plus 5. What's the degree of that polynomial?
Will be 2, right?
Yeah. And another question, is the divisor in a standard form?
Can you repeat that, please?
Is the divisor 2x squared plus 5 in the standard form?
I would say no.
You're right. What is missing?
I don't know. Is
How
it
should we write
standard
it?
forms A plus B equals C, right? Or A plus B?
So
Plus C.
missing degree 1, right?
Yes.
Because the coefficient is 0. So if we write 2x squared plus 5 in the standard form, that's going to be 2x squared plus 0x plus 5. Do you agree?
Mm-hmm.
Okay, awesome. So is the audio always like this? You don't hear me well?
Yes.
So you
Yeah,
don't.
I was just away from my computer.
Oh, you're awake. So is
Yeah.
the audio okay? I just want to make sure.
Yeah.
Because this semester this class is the first time I use Zoom. I
Yeah.
used to use the Blackboard Ultra Collaborate,
Oh,
but
yeah,
this
audio is good.
audio is good. Oh, okay, okay,
Mhm.
very good.
Yeah,
All
audio
right.
is good.
I think it was
Okay.
just my phone that was messing up. I don't think it was you.
Oh, okay. Yeah, just
Yeah.
want to know because the first time I used the system.
Yeah.
All right. So to use long division to divide one polynomial by another polynomial, up front we need to write both polynomials in a standard form. Very, very, very important. Okay. A lot of people messed up because they forgot doing this. You have to write both dividend and the divisor in a standard form. Okay, now let's start the long division. We're going to put the dividend under the division symbol. This is also a division symbol, okay? It's different from the radical symbol. Radical symbol looks like that. It's a little bit different. So we're gonna put the dividend, the standard form of dividend under the roof. 2x cubed minus 4x squared plus 7x minus 8. And we're going to put the standard form of the divisor to the left of the symbol next to the symbol, which is 2x squared plus 0x plus 5. Knowing the 0x here is necessary, is very important. For both dividend and divisor, if they are given, if the given form is not standard, you have to rewrite the polynomials in a standard form and then place them like this. Dividend under the symbol and the divisor to the left next to it, all right? So the process of long division includes the following steps. Divide, multiply, subtract, compare, bring down. Okay, so I'm gonna explain what is divide, what is multiply, what is subtract, compare, and bring down. Divide here is divide the leading term. You should take a, if you haven't learned this method or you didn't learn it well before, you need to take a note. Divide the leading term of the dividend by the leading term of the divisor. All right, so that's the first step. Leading term of the dividend. This is the leading term of dividend. Divide that by the leading term of divisor. This is the leading term of divisor. Let's see what we have. 2x cubed divided by 2x squared. 2 cancel 2, x cubed over x, right? So we got a quotient x, and we are going to put a quotient x above the division symbol and align with 7x because 7x and x, they are like terms. We need to vertically align all the terms that are like terms. just like that. And multiply. Multiply what? Multiply the quotient we got from step 1, multiply the quotient we just got by the divisor. Okay, so the quotient we got is x. Multiply x by the divisor, which is 2x squared plus 0x plus 5. And let's distribute. X times 2x squared, 2x cubed. X times 0x, 0x squared. X times 5, 5x. Once we have the multiplication, we're going to place the product, the result, under the symbol, okay? Under the dividend. Under the dividend, we're going to have 2x cubed plus 0x squared plus 5x. All right, just like that. And the next step, subtract. Subtract the result or the product we got from the terms above them. Knowing long division requires all the vertically aligned terms are like terms. So we have to put 2x cubed under 2x cubed, 0x squared under negative 4x squared, 5x under 7x, because we need to make sure vertically aligned terms are like terms with the same degree. Okay, so subtract vertically is not convenient. So instead of subtracting here, we're gonna do is, instead of subtracting, we are going to change the subtraction to addition and change all the terms to their opposite. So 2 become -2, 0 become -0, 5 becomes -5, all right? And then we add them together. So we have 2x cubed plus -2x cubed, they cancel, right? So we do not have x cubed anymore. And -4x squared minus 0x squared, we get -4x squared. Positive 7x minus 5x, so that's 2x, right? So that's one round, almost one round. And then we compare what? Compare the difference, the degree of the difference with the degree of the divisor. So this is the remainder. Okay, I can write the remainder here. The remainder. This is the remainder in the first round, okay? Degree is 2, right? And the degree of the divisor is 2 as well. And we have to continue. We only stop when the remainder has a smaller degree than the divisor. And that's also important, okay? We stop the process of long division when the remainder has a smaller, strictly smaller degree than the divisor. Now it's not. The remainder has degree 2, the divisor also has degree 2, so we have to continue, right? Continue, bring it down. If we decide to continue, we bring it down. Bring down what? Bring down the next term. If the remainder degree is not less than the degree of the divisor, bring down next term in the original dividend. All right, so in the original dividend, so next term in the original dividend is -8, so bring it down. And now this guy, is the new dividend. All right, we finished the first round. We're gonna start the second round. The second round, the dividend is 94x squared plus 2x minus 8, the yellow one, the one I'm highlighting in yellow. And we start the second round, divide, multiply, subtract, compare, bring down. All right, so divide what by what? Divide the leading term in a dividend, that's the new dividend, by the leading term in a divisor. So 94x squared over 2x squared. And the quotient is 92. I'm going to put a quotient 92 above the dividend, right? And that's divide. Multiply the quotient we got, which is 92, by the divisor, 2x squared plus 0x plus 5. Distribute 92 times 2, 94, x squared, 92 times 0x, 0x, 92 times 5, 10. And then place that under the new dividend. So we have 94 x squared plus 0x minus 10. And then subtract. All right, we're going to subtract the product we placed under the new dividend from the terms above it. And then the same thing, if we subtract vertically, it's not convenient. Sometimes people mess up the sign. So we are going to do adding the opposite. So we change negative to positive, negative to positive to negative, and negative to positive. And then we add them together. 94x squared, positive 4x squared, they cancel. 2x minus 0x, 2x. Negative 8 plus 10, positive 2. All right. And let me double check here. 2x cubed. Let me double check my work here. So 2x cubed plus 0x squared minus plus 5x, 2x, negative 4x squared minus 8, negative 2, negative 4x squared, 0x minus 10. Okay, I think everything looks good. Negative a plus 10 is 2. Okay, and compare. This is the remainder of the second round. 2x plus 2 is the remainder of the second round. This remainder has degree 1. All right, degree 1, which is strictly less than the degree of the divisor, which is 2. And we are done. Okay, when do we stop the long division process? When we have a remainder whose degree is strictly less than the degree of the divisor, then we stop. Okay, then we can look at this. What do we have here? And first, I want to demonstrate how clean, how organized the long division process. And all the vertically aligned terms have to be like term. Like this column, x cubed, right? And this column, degree 2, 2, 2, x squared. And this column, x, 7x, all the terms in this column, they are x, like terms. And the last column, all those terms are constants. So that's very important for long division. Okay, so we have this here. We have a polynomial above the division symbol, and that's our quotient. And we also have a polynomial at the bottom in the end, and that is the remainder. And we know this polynomial in the under the symbol, that's the dividend. And here, this polynomial is a divisor, right? So I want you to see the four things, the four polynomials, they play different roles and their locations in the long division arrangement. Dividend is under the division symbol. Divisor is next to the division symbol, to the left of division symbol. And the quotient is above the division symbol. The remainder is at the very bottom. of the arrangement. All right, then we can conclude the quotient is the blue one. The quotient is the blue one, x minus 2. The remainder is the green one, 2x plus 2. That's how do we answer it. All right, so that's the long division process. I recorded a class so you can rewatch later. The second method we're going to learn is called synthetic method. Long division method is good, but it's very challenging for some people. And so we have a better method. It's called synthetic method. This method is very easy to apply. Once you grasp, it's very easy to apply. But the disadvantage of the synthetic method is it only applies. This method only applies when the divisor has degree 1 and the leading coefficient is also 1. Synthetic method is good, but this method only applies when the divisor is in this form, x plus k, or at x minus k. It doesn't matter, depends on the sign, okay? Divisor has to be in this form, divisor, like x plus 5 or x minus 10, right? Something like that. Now let me show you how do we apply synthetic method to process this problem. The dividend is above the division bar, x to the power 4th plus x cubed minus 40x plus 13. That's the numerator of the quotient, which is the dividend. Okay, let me write it down. Dividend. Dividend has degree 4, as you can see. Right? I have a question. Is the dividend in a standard form? Earlier, when we learned the long division method, I emphasized up front, you have to rewrite both dividend and divisor in a standard form. The same thing to the synthetic method. We also need to make sure both dividend and divisor are in the standard form. Is the numerator dividend in a standard form? Ether? Is x to the power 4th, degrees 4, plus x to the power 3. Do we have x squared? We do not have x squared because the coefficient is 0, right? So we can write 0 times x squared, and then minus 40x plus 13. In this case, the dividend is not in the standard form. We need to rewrite the dividend in the standard form. X to the power 4th plus x cubed plus 0 times x squared minus 40x plus 13. So if you count the number of terms in the polynomial, 1, 2, 3, 4, 5 terms. That's the standard form. Divisor. Divisor is degree 1, has degree 1, is linear. And it is in a standard form, okay? X minus 3. All right, so now let's do the synthetic method. Draw a long bigger L. And then we are going to put the coefficients of the dividend like this. The coefficient of x 4th is 1. Coefficient of x cubed is also 1. Coefficient of x squared is 0. Coefficient of x is negative 40. Coefficient of the constant is 13 positive. So we're going to put those coefficients in the same order do not mess up the order. 1, 1, 0, negative 40, 0, 1, 1, 0, negative 40, and 13. Right? And then we are going to put a k right here. X minus k is a divisor. So in this case, in our problem, k is 3. The number, the x is minusing. If we have x plus 5, then k would be negative 5, all right? Just be aware of that. If the divisor is x plus 5, then the number we are going to place right here is going to be negative 5. In our problem, we are going to put a k, which is 3, next to the big L. All right, let me adjust this synthetic, this big L. Okay, let's start it. We bring down 1. 1 times 3 is 3. Put it here. Add 1 and 3 together, we have 4. Multiply 4 by 3, 12. Put it here. 0 plus 12 is 12. 12 times 3, 36. Put it here. Negative 40 plus 36 is negative 4. Negative 4 times 3, negative 12. Put it here. 13 minus 12 is 1. And we're done. We're done with the arrangement for the synthetic method. All right? And how do we identify the quotient and remainder from the result? Let's look at the bottom. Let's look at the bottom. From right to the left, we are going to do from right to the left, okay? This number is going to be the remainder, okay? This is the remainder. Remainder. And how do we find the quotient? We look at those 4 numbers. We're going to do this. We're going to go to the from the right to the left, right? 94 is going to keep as 94 as a constant, and 12 is going to be 12 times x. Put a variable x here. And 4 is going to be 4 times x squared. Put a square x squared on here. And then 1 is going to be 1 times x cubed. Do you see the pattern? And this is the quotient. That is the quotient. Do you see it? It's very important. I don't know if you were paying attention. Do you have any questions, guys?
No, I understand it.
Okay, perfect. Yeah, let me look at my work. And another thing I want to ask you to do is this. Okay, let's do some work here. So if I let something extra, okay, has nothing to do with the synthetic method. If we let f of x be the dividend, is x to the power 4th plus x cubed minus 40x plus 13. Can you help me to find out what is f of 3? You have a calculator? Yeah. Could you help me to find out what is f of 3? I'll give you 1 minute and let me know what you have, all right? What do you have? What is f of 3, guys?
I got 241.
Oh, too much. It's not that. Jose, did you try?
Oh, I put plus instead of negative.
What about Eliza? Did you try Ether?
I'm still trying it.
Oh,
Give
take
me
your time.
like, yeah, thank you.
Is it 1?
Yes, awesome. It's the remainder. I want you to remember that. All right, isn't that interesting? It is a remainder 1. Always like that, all right? Okay, let's practice another problems. Let's practice this one. Okay, so the dividend is x cubed minus 10x squared. It's missing degree 1, right? Numerator, the dividend has degree 3. The polynomial has degree 3. The standard form is supposed to have 4 terms, but it only has 3 terms. That means there's 1 term is missing. We have to write it out. 0 times x, and then plus 148. Now we have x minus 3, 2, 1, 0. X cubed minus 10x squared plus 0x plus 148. So that's dividend. Divisor, x minus 6. It's in the format x minus k, right? Okay. So our k is 6. Let's do the synthetic method. Coefficient of x squared, coefficient of x cubed is 1. Coefficient of x squared is negative 10. Coefficient of x is 0. Coefficient of the constant term is a positive 108. So we are going to place those numbers like this: 1, negative 10, 0, 148. 1, negative 10, 0, 148. And then we place 6, the k, right next to the big L on the left side. Okay, start the synthetic very quick. 1, bring down 1. 1 times 6, 6. Negative 10 plus 6, negative 4. Negative 4 times 6, negative 24. 0 plus negative 24, negative 24. And then negative 24 times 6. Let's see, what is 24 times 6? 144, right? Yeah. Negative 24 times 6 is a negative 144. And 148 minus 144, positive 4. And now we can identify this is a remainder. And those 3 numbers gonna give us the quotient. The quotient is going to be 1x. So we can go from right to the left is better. So keep this as a constant. And every time we go to the left, the degree is going to go up by 1. And this is negative 4x. And it's going to be 1x squared. So this is the quotient. Right? Quotient. So in this case, dividend has degree 3. Divisor has degree 1. So 3 minus 1 is 2. The quotient is supposed to have degree 2, and it does. And the remainder is a constant. And so the quotient is x squared minus 4x minus 24. Remainder is 4. So I want you to help me to calculate if we let f of x equals the dividend, which is x cubed minus 10x squared plus 148. Can you help me to find out what is f of 6? F of k, f of 6. 1 minute. Let me repeat my question. If we let the dividend be f of x, the polynomial function, f of x equals x cubed minus 10x squared plus 148. Can you help me to find the value of f of 6? Please help me to find the value of f of 6.
Do you want the answer already, or do you want to
Yeah,
give
you
everybody
have the
time
answer?
step? I
Yeah,
got
what's the
304.
too much? Too much.
Okay.
Yeah, could you double check your work?
I got 4.
You got a 4?
Yes.
4 is correct. Yeah. 4 is correct. It's the remainder. If you haven't seen the pattern yet, let me show you the pattern again. F of x is the numerator, and the number I asked you to plug in is the k on the denominator, right? And the result, when you plug in k equals 3, the result is always equal to the remainder. The remainder is 1. Same with this problem. We let the dividend be the polynomial function, and we plug in x equals k, which is 6, and the result supposed to be the remainder. After we got apply the synthetic method, the remainder is 4, right? It is 4. You see that? I hope you see the pattern, because later we're gonna have a theorem about it. Let's see, do I have more questions about synthetic method? Okay, this one can be, this one we can use synthetic method, right? Yeah. I'll give you 3 minutes. Could you practice on this one? Use the synthetic method. Dividend. Yeah, this is your practice. Dividend is x cubed plus 8x squared plus 17x plus 13. The dividend is already in the standard form. Divisor, x plus 2. Remember, synthetic method only applies when the divisor is in this form. And when you know what is k. In this case, k is -2, okay? K is -2. Yeah, this is the first time we see a negative k. K is -2 because x plus 2 is x minus -2. X plus 2 is x minus -2. So k is -2. I'll give you a couple minutes. Okay, guys, what's the quotient?
It's x squared plus 6x equals, plus 5, not equals. And then the remainder I got 3.
The remainder is correct, 3. What's the quotient again? Could you repeat it?
Yep, sorry. X squared plus 6x equals 5.
Plus 5.
I'm sorry, I did it again.
Yeah, you're very close. You're great. Yeah, thank you. The remainder is 3. Very good. And those 3 numbers gives us the coefficients of the quotient. It's going to be 5. Yeah, they're all added together, okay? 6x, x squared, 1 times x squared. So the quotient, this is the quotient. The quotient is x squared plus 6x plus 5. All right, I'm going to ask you to do another thing. If we let f of x as the numerator, which is x cubed plus 8x squared plus 17x plus 13, what is f of 92? Yeah, be careful because this time you're plugging in a negative number. What is f of 92? If you're plugging in -2 into the polynomial function, what do you have? Evaluating a polynomial function is also a requirement, core content of this course. So this is an opportunity to practice that topic.
I got 3.
Awesome, exactly. Remainder 3, right? You got a remainder. You must have the result equal to the remainder. Okay, very good. And this problem, I have a question. Can we use the synthetic method? This one? Numerator, dividend. Can we
Is
use the
it
synthetic
no
method?
because of the 4?
Yes. Yes, we can't, okay? We would have to use long division. Let's use long division to process this problem. So we have dividend -12x cubed minus 23x squared, 6x, 25. Degree 3, 1, 2, 3, 4, 3, 2, 1, 0. Okay, it's already in the standard form. Divisor. Divisor is 4x plus 5. Also in the standard form already. Okay, let's do the long division. This is standard form. Standard form. Okay. And we put the dividend under the roof. Then 12x cubed minus 23x squared plus 6x plus 25. Now we put a divisor right here. And we are going to repeat the process. Let me run the process here. Divide, multiply, subtract, compare, bring down. Okay. Divide what by what? Divide the leading term in the dividend by the leading term in the divisor. -12x cubed over 4x. -12 over 4 is 93. X cubed over x squared. So the quotient is 93x squared. 93x squared. And we put 93x squared above 23x squared because, again, in long division, all the vertically aligned terms must be like terms, right? Okay, so multiply. Multiply what by what? Multiply the quotient, which is the gap, by the divisor. 93x squared times 4x plus 5. Distribute. 93 times 4, 12. X squared times x, x cubed. 93x squared times 5, 15x squared. And we place the product right under the dividend. Yeah, again, make sure all the terms, like terms, are vertically aligned. 12 x cubed minus 15 x squared. And then subtract. Instead of subtracting vertically, we want adding vertically. So we change the subtraction as division, subtraction as addition, and then change minus to positive, minus to positive, minus to plus, and then we add them together. 12x cubed, positive 12x cubed, they cancel. 23x squared, positive 15x squared, and that gives us negative 8x squared. 23 minus 15 is 8, right? It's negative. Okay, and then compare. This is the remainder of the first round. Degree is 2. Degree is higher than the degree of the divisor, which is 1. So we have to continue to bring down the next term in the original dividend, which is 6x. And now this polynomial is going to be the new dividend, and we're going to start the second round. Divide the leading term in the dividend by the leading term in the divisor. Let me clean up this part. Negative ax squared over 4x. Negative a over 4 is negative 2. X squared over x is x. So negative 2x is the quotient. We put it here. Negative 2x. Multiply the quotient by the divisor, 4x plus 5. Distribute. Negative 2 times 4, negative 8, x times x, x squared. Negative 2x times 5, negative 10x. Place the product right below the dividend, negative ax squared minus 10x. And then subtract. And then we do keep change. Change this to addition, this negative as positive, this negative as positive. And then we add them together. Negative ax squared, positive ax squared cancel each other. 6x plus 10x, 16x. Okay? And then compare. This is the remainder of second round. Degree is 1, which is not less than the degree of the divisor. We have to keep going, bring down the next term in the original dividend, which is positive 25. And then start again. Start a third round. Okay, start the third round. This is gonna be the new dividend. And divide the leading term of dividend by the leading term of the divisor. So we have 16x over 4x gives us a 4. We put a 4 here, align with those constants. And multiply the 4 by the divisor, 4x plus 5. Distribute. 4 times 4, 16, 16x. 4 times 5, 20. And place that under the 16x plus 25. Subtract. And we can do plus the opposite. So this is negative, this is also negative, right? 16x, negative 16x add up to 0. 25 minus 25. And then compare. 5 is a constant. 5 is a constant, has degree 0, right? 5 is a constant, has degree 0. And it is the remainder 5 is a degree 0, which is less than the degree of the divisor. So we are done. And 5 is the remainder. Quotient is right here. Quotient. Right? The last thing today is to know a format. quotient plus remainder over divisor format. So we need to know if we divide a polynomial, let's say the polynomial is dividend, by another polynomial is going to be the divisor. The result can be written as quotient plus remainder over divisor. Like for this problem, be sure to enter your answer in quotient plus remainder over divisor form. Then the answer the system expecting to see is going to be, the answer is going to be quotient, that is 3x squared minus 2x plus 4 plus remainder. What's the remainder we have? 5. Okay, 5 over divisor. Divisor is 4x plus 5. So that's the answer the system expects you to enter in the box. All right, guys, so that's everything for today. We learned the definition of a polynomial, and we also learned 2 different methods to divide polynomials. When the divisor is in a specific format, like x minus k, we can use a synthetic method. It's a very good method. I believe everybody loves it. But if the divisor is not in that format, we cannot apply a synthetic method. We have to use long division. All right. So today is the last class before spring break. I will see you 25th, right? Yeah. Feel free to email me if you have any questions. Thank you, guys. Have a good break.
You too. Thank you.
Thank you.
You're welcome. Bye-bye.